Variety testing is complex. We know that varieties have genetics, and we know they have an interaction with the environment. So the concept is that we can't grow a single replicate of a variety in the field. We need to grow at least 3 replicates of that variety in different parts of the field, because we know the field is non-uniform. There's differences in soil, there's differences potentially in pH, there's differences in drainage, water usage inside the soil. Hi, I'm Julian Taylor, and I lead analytics for the Australian grains industry. It's a GRDC funded initiative that helps support the grains industry through robust analytics. We're at the NVT Palmer site. It's about an hour out of Adelaide, and it's got 40 varieties that are being tested out in the field through 40 rows and 3 columns.
Through the NVT, a grower can at the start of the season look at our results and look at the NVT growing information and know which variety is going to perform best in their environment. I am Nick Lambert from Adelaide University. I'm a biometrician within the biometry hub there as part of the AAGI project, and I handle a lot of the analysis for the NVT analytics project. A single rep trial is a trial where each variety is only in the paddock once. It only has 1 replication. So this means that there could be 40 varieties and there'd only be 40 plots with each variety in 1 plot each. So we typically don't use single replication trials anymore because statistically they have a lot of problems. The major one is that if we only have 1 replication of a variety, we're unable to separate the variety effects from any other effects that are going on in the field. So whether that's soil or pH or salinity or anything like that, we don't know if the variety is performing well or poorly, or if it's just in a good or bad part of the field. In the NVT, we always use 3 replications. That's standard across all trials. We have 3 replicates of every variety in each trial, and these are in 3 blocks each. So each block has 1 variety. We block our trials in 2 directions. This means that there's a block going on in the range direction and then also a block going on in the row direction.
The beauty of adding replication is that we can then suddenly access all the other components of variation that are going on inside this trial. That includes genetic associated with the varieties, as well as all the non-genetic, the environmental variation that you can't really see when you stand out in this field.
And using this, we can tell if, for example, the first column block is yielding very well and then the other 2 aren't. We can use our blocking design to really nail down and separate this field effect from the actual variety effect. And this way we can tell whether the varieties are performing well or whether they're just in a good part of the field. Within the NVT, we do 2 types of analysis. The first is the single site analysis, or SS, if you've seen that anywhere. And that's where we analyse everything that happens at an individual trial. Then we go further and do a meta-analysis, which is a multi-environment trial analysis, where we stack up all the trials within a region, or in some cases across Australia on a national level, and we analyse all the data points together.
And that gives us an indication about what occurs with the varieties occurring across all of these sites. We can then genetically connect these sites to give that analysis power.
When we go to a meta approach, it gives us a bigger sample size. So if we have 3 reps of every variety at a single trial, then we add lots more trials together. We're going to end up with a lot more replicates of each variety. And so we can connect these using these varieties that are planted at every single trial to analyse as a data set together. And because we have then a bigger sample size of each variety, our results get better. So this gives us more precision, more accuracy, and reduces our standard error.
And that is one of the most critical things here in a meta-analysis. We can bring power to the analysis, and that allows us to reduce uncertainty of the variety effects across that particular region.
Connectivity refers to how many varieties are in common between 2 trials. So is the same variety grown at trial A that is also grown at trial B? And so if we have lots of varieties that are in common, we have a good connectivity, and this allows us to analyse the 2 trials together, which gives us more data and essentially better results because we have more accuracy. With greater connectivity, It means that if a variety wasn't grown in an environment, through the meta-analysis we can predict how it would perform if it was grown in that environment, which is one of the big strengths of the Met. If you don't grow, say, variety A in environment A, but you did grow it in environment B, C and D, we can then use the meta-analysis to predict it back into that original environment where it wasn't present.
One of the key things for NVT analytics is that we can take a single site trial and we can connect it with a whole bunch of other trials in the adjacent regions. And that allows us to bring power, accuracy, and much more confidence to the growers and farmers in the results that we produce.
A grower can, at the start of the season, look at our results and look at the NVT growing information and know which variety is going to perform best in their environment. They can be comfortable that our meta-analysis is robust and that it's handled all the data well, and the analysis is at the cutting edge, it's the best it can be. And this means that they can grow things that work best for them.